Okay, so now in this video, we are going to look at the third part, which is the electronic configuration. And then, the other part is the conversions and all. So electronic configuration is like more important. Electronic configuration is more important. So in electronic configuration, just make sure that you have somewhere you understand or you have written this order. If you have the order written, then you are like gold, no problem. So here is 1s2, 2s2, the filling, 3s2, 3p6. Oh, sorry, I'm moving fast. Sorry about that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and after 5s2 is 4d10, 5s2, 4d10, then 4d10, after that is 5p6, then 6s2, then after that is 6s2 is 4f14, and then comes 5d10, and then is 6p6, and then comes 7s2, and then comes 5f14, and so forth. Okay, 5f14, and then so forth. So this is the order of filling. So make a note of it. You should make a note of it or know it or memorize it or whatever works for you. Or you can use the handout where it is shown in a zigzag fashion. You can use that also. Okay, so the rest is simple stuff. So, okay, so there's a question here, and they're saying one of the chapter 3 question 83b, the answer skipped 3d10 from 4s2, went to 4p6. Now, okay, Jessica, I do not know 83b, what is that question? And so you have to write down the full question. Okay, so give me the full detail so that I know which particular question is that. I don't memorize the questions. I don't know which one it is. 83b, which one is that? Okay, so give the full question. Okay, now, anyway, so let's look at now the electrode. So one question can be asked is write the, like the, the ground state. One is the ground state. Ground state. Ground state is just the normal, right? And this is the expanded notation, right? Then the other one is the noble gas configuration. That's the question. Noble gas means you have to condense it. So that is the condensed version. Okay. And then there's also, just so you know, there's also the excited state. Excited state is the one where the electrons are, lost or gained. So that happens in the excited state. So this applies to the ions, right? So ions that are lost will give a positive charge, positive charge, and then gained will show a negative charge on the ions. Okay, so ground state. So first, so one question can be asked, and also like you can also be asked about the orbitals, and you will also be asked about the, excuse me. One second, excuse me. I have to look at a few here. This one is going to be fast comparatively. Okay, so orbital diagrams. So let's say, for example, we are doing the electronic configuration of, we did for iron, copper. Let's do for manganese, right? Mn, manganese 25. Okay, so manganese 25 is 1s2, 2s2, 2p6, 3s2, 3p6. After 3p6 is 4s2 and 3d5. So the placement of manganese is in the third, in the 3d, in the 3d, in the d orbit, in the d 3d5 means that in the third shell, D stands for the block, and 5 stands for the column. Okay, column. So in the fifth, like in the column is the fifth column in D block. Okay, so besides that, if you count 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 plus 2, 20 and plus 5, 25. So it adds up that way also. So this is the expanded version. Okay, this is the expanded version. Now, if the question is saying, do the condensed, so you are only going to look at the nearest noble gas, which is like one level above. So this one is 10 neon, but let's see if we have 10 plus 2, 12 plus 6, 18. And then the remaining is, leave it. So here, this inner core, so these are the 18 electrons are of argon accounted for. So all these ones from here till here, all of them. All of them are placed in argon. Then you're left with 4s2 and 3d5. Okay, so this looks kind of ugly. This is better. Okay, so all the 18. So 3d5. Now, the question can be asked, what are the valence electrons? So the multiple choice already obviously valence. The multiple choice will give you 3d5, so don't choose that. Valence electrons are 4s2 because it is in the highest shell number. 4 is more than 3, no matter where the 3 is placed. So it's the 4s2. So there are 2 valence electrons in manganese. Okay, that's what it means. So with that said, the Lewis structure of manganese would be 2 dots. Okay, and now if they're saying write the orbital diagram. Okay, orbital diagram. Orbital diagram is, in this case, so we are going to place argon is 18, and then comes 4s2 and 3d5. So you're going to put 4s2. D can hold a maximum of, D has 5 orbitals, 1, 2, 3, 4, 5. So here, first this, and then D5 are singly occupied. Okay, 5. So this is the 3d5, and this is the 4s2. Okay. All right. So we have this 3d5 and 4s2. So that's the like the placement, the orbital diagrams. Okay. So if the question is asked Mn plus 2, so what is that? So that in that case is argon inner core, where those are not removed. 4s2 becomes 0. 4s2 is 0. No electrons there. 0 means nothing. But the 3d5 still stays. Okay, so you have to keep this in mind that we are writing. There is a difference. Sometimes it's the visual thing. Students forget that here is the nucleus and the energy levels. 1 energy level, 2nd energy level, 3rd energy level, 4th and 5th, and like all this is like, like this is the real structure of atom. It's all like jumbled up. And it's when we write the electronic configuration, we write with respect to how the nucleus sees them. So nucleus will see, let's say this is the eye of the nucleus. This is the nucleus looking at them. So nucleus, I forgot the spelling, Nucleus, or nuclear eye. So nucleus is able to see like all these 18, and then it's able to see 4s more, and it will still see 3D, but not as much as 4s. Even now the 4s is gone, so yeah, it will see 3D more, right? But that doesn't mean that the forest doesn't exist. That place is still there. That energy level is still there. It's just vacant now. Okay, so that's how you will put. So this is one. Let's do for, let's say, so we did for sulfur. Let's do for phosphorus. Phosphorus is 15. Okay, so 1s2, 2s2, 2p6. No, phosphorus is 15. So 15, 6, yeah, and then 3s2 and 3p5, 3p3. So it is in the third period P block, and on the energy levels are like 3 electrons, third column. Okay, so here the inner core are these. So that's a neon. So that looks like neon. This is neon. Neon 10. And then this 3s2 and 3p5, 3p3. So these are the this one and this one, these are the valence electrons. Valence electrons. Valence electrons are valence electrons. Highest shell number, all of them are counted. Valence electrons. So there is valence electrons are 2 plus 3 is equal to 5 electrons. So 2 plus 3, 2 plus 3, all of them are counted. And that's why phosphorus will have 1, 2, 3, 4, 5. 5 electrons, you know, we show them as dots, the Lewis structure like that. Okay, so that's the phosphorus 5, and then that's what it is. And then if they ask you draw the diagram, like the orbital diagram, 1, 2, 3. So here you will see you have 1, 2 for the 3s2, and 3p3 is all spread out like that. So this is the 3p3, and this is 3s2. Okay, now if they say phosphide minus 3, how would you do? In that case, it is actually 15. Minus 3 does not mean minus 3. No, it is added 3 more electrons. So that is why it becomes 18, total of 18 electrons. And these 18 electrons are like argon. So phosphorus prefers to gain. P minus means gain electrons, gain 3 more electrons, 3 electrons, so that it gets octet. You know, octet is 8 electrons. So it already has 5 plus 3 more, and it gets 8 electrons. That's one reason. And second thing is it will have fully filled p orbitals, fully filled p. All right, now we have here phosphorus 15, and that is 1s2, 2s2, sorry, not 15, sorry, now we are looking at phosphide, sorry. So phosphide is phosphide p minus 3. Inner core argon 18, and then 3s2 and 3p6. 3p6. So there were 3 here. So there were 2 here. There were 3 here initially, plus you added 3 more, and that makes it 8 electrons in that. And then if you look at the orbital diagram, 3. So here you have 2 electrons, and the p6 is all covered, all filled. First singly occupy, and then pair. All right. So that gives you the, you know, a picture of like the placement of the electrons and the valence electrons, and again the Lewis structures and electronic configuration. Okay, and so what was that question you were talking about here? Okay, it says write a complete electronic configuration of atoms whose electron configuration ends as follows. Problem solved, which ends at 47. Okay, that's the one you're talking about. So it's not skipping or anything. It is not skipping. So your question here is saying, okay, let's do this question. Write the electronic configuration, that's a homework question, of write the electronic configuration for atoms whose electron configuration ends as 4d7. So write the electronic configuration of atoms that end at 4d7. So how do you know which one it is? So the one, so remember, this is the placement that we are talking, okay? Plus placement is 4. Which element are we talking about, first of all? We are looking at the one that is going to end at 4d7. So this means the fourth period, D block, the element that is in the fourth period, D block, and is in the seventh column in D block, seventh column in D block. Okay, so identify that one. Fourth period. Now let's look at this. Probably there's another thing that might be confusing you guys. So it's this thing. Look here, modules. Okay, here is, look at this one right here. Now I wish I could make this. So here you see this. This is 1A, 1A, and 2A are the S blocks. 1A, 2A are the S blocks. The first column mean it's going to be, all of them will have S1. The second column will have S2, okay? Whether it's 1s2, 2s2, 3, it depends on the period. So hydrogen, period 1, lithium, beryllium, period 2. Period means energy level. Hydrogen, 1 energy level, lithium, beryllium, 2 energy levels, sodium, magnesium, 3 energy level, potassium, calcium, 4 energy level, rubidium, strontium, 5, cesium, barium, 6, francium, radium, 7, and so forth. Okay, so here these energy levels signify that first, so it would be, lithium would be 2s1, beryllium is 2s2, sodium is 3s1, magnesium is 3s2, calcium is 4s1, no, sorry, potassium is 4s1, calcium is 4s2, and so forth. Okay, so that's one piece. Second thing is this guy over here. Potassium and calcium are 4s, right? But scandium, starting point right here, where is 21, make a note here. The starting is 3D. The starting here is 3D. Scandium. So make a note of it here. Similarly, Y, where it says Y, 39, the starting is 4D. Whereas RB and SR, rubidium and strontium, these guys are in 5S. But ytterbium, it's the yttrium. Yttrium 39 is starting at 4D. Okay, now all this 4D, 3D on the top one, 4D bottom one, and then these goes, finish. Now, after zinc, you see Ga, gallium, and germanium. These are starting back to 4P. So after zinc ends at 3D, after that starts gallium. That is at 4P. Similarly, cadmium ends at 4D. Indium is 5P and tin 5P and so forth. So this you have to make a note. And now we are now looking at the 4D7. So fourth column, 1, 2, 3, 4. 4D. 4D will be starting where it says Y. So 4D will be Y. This one, starting from Y, starting from here. This energy level we are looking at. 4D. D is the D block. And seventh column. So 1, 2, 3, 4, 5, 6, 7. Seventh is this rhodium, RH. This one. Rhodium. So number 45. So this is, they're saying fine. So that is, all of them are going to end in 4D 7. So let's do number 45. RH 45. Okay. RH is 45. And now just do it similarly. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, okay, 4p6, 5s2, after 4p6, 5s2, after 5p6 is 4d, 4d, so we are looking at, after that is 4, so since we have reached the 4d, after 5s2 is the 4d, we reached 4d and 7. There's 4D 10. 10 is the maximum, but we need to place only 7. So 7th column, 7. Okay, so we can count also. Count 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18. Keep going. 18 plus 2, 20. 20 plus 10, 30. 30 plus 6 is 36. And let's see if we have the P blocks, the end of the P block, 36 is the electronic configuration of krypton. So they are wanting you to do it for like in the expanded, but I'm just showing you how krypton got here. Krypton 36, inner core. You can, like, if the condensed is given. So then you can just focus on the outer ones. 5. So this is 5, S2, and 4D7. Okay, so that's what's left now. So even though this is the D7, but this is still going to be the valence shell. So there are 2 valence electrons. Okay. So complete is on the top, but the bottom. So now they are saying do all. The 4, so there can only be one, not all. There can't be many because there's only one. The next one is going to be in 5D. The other one is in 6D and 7D and so forth. You get that? So only one you're writing. Is that clear, Jessica? Hello, Jessica. Is that clear?
Sorry, yeah, I was just looking when we were doing
Are you there?
Yes,
Jessica?
I'm here. Can you hear me?
All right, okay, I hope that's clear, but that's the way to do it. So you have to look at the placement, okay? And then go from there. All right, so this was regarding the, things, and the other general simple questions. So can be asked, like basic questions. Like S, P, D, and F orbitals. So S orbitals can hold how many electrons? 2 electrons. P can hold a maximum of 6 electrons. D can hold a maximum of 10 electrons. And F can hold a maximum of 14 electrons. Another thing is S orbitals, P orbitals, D orbitals, and F orbitals. So these are the subshells, and we have here orbitals. Okay, so S orbital only 1, P has got 3, D has 5, and 7 has, the F has 7. Okay, so okay, so I'm looking at these chats. So you're saying, David, she has everyone mute. Yeah, I have muted everyone, but that's what I'm saying. The communication is through the chat, and I can see when you write the chat. So Vanessa was asking, why doesn't all the orbitals always go in order? Why don't all the orbitals, is that what you are, is that, okay, Jessica, okay. Okay, Vanessa is asking, why don't all the orbitals go in the order? Vanessa, we talked about the order of filling is depending upon how the nucleus sees them. We talked about shielding effect. We talked about less nuclear pull. We talked about the overlap, right? So the order is not like, it's not nice linear order. The overlap begins to occur here, right? Overlap begins to occur at this site after 3p. So this is a nice linear order from 1s2, 2s2, 2p6, 3s2, 3p6. But after 3p6, 4s2 comes, then 3d, then 4p, then. So this is all the overlap that occurs because the electrons go further away. The further away the electrons are from the nucleus, the electrons have more freedom. There is more freedom, and the electrons can be, when the electrons have freedom, they move, very easily. And the nucleus, we write the electronic configuration, how the nucleus is seeing the electrons. So nucleus sees S more than the P, and P's are more than the D, and D is more than the F, okay? So that's how it is. But nonetheless, the electrons are always spinning on their orbits. I mean, in their orbits, they're always spinning, they're rotating, they're revolving. But, sometimes they're close to the nucleus, sometimes they're further away in their energy level. So the electronic configuration is based on that thing. So the nuclear pull is very less on the outermost electrons. So that is why they are seen less by the nucleus. Nuclear pull is more on the inner, like near the ones that are near the nucleus. 1s2, 2s2, 2p6, 3s2, 3p6. These guys, these 18 electrons are seen more by the nucleus because they are very close to the nucleus. Further away they go from the nucleus, this overlap begins to occur. Okay. All right, so we covered that in detail, but next is Jessica. Okay. Answer in the back of the book is completely skipped 3D10. It goes from 4s2 to 4p6 as the answer. I just wanted to make sure I did it correctly. Okay. Okay, then if it's at the back, if they skip 3D10, that is a mistake. That is a mistake. But thank you for pointing out. I'm going to make a note of it. There are, there are some errors in the book, and it's a good that you do them on the way you understand. You do them and you connect with me and verify. So I'm going to send me an email about this question, so the whole class should know that this is a mistake in that question. Okay, but thank you for letting me know, Jessica. Very well done, actually. Very good. I'm glad we clarified this here. Okay. All right, guys. All right. Okay. Thank you, Jessica. Okay, just send me an email because I might forget. Okay, so these type of questions, I guess, are easy. Then the thing that you also need to do is the abundance factor, the abundance, and the abundance, the percentage, multiply by the mass number that is given to you, and then that's going to add up and makes the average isotopic mass. So we covered that in the class. Just look at it. Average isotopic mass. Okay, average isotopic mass. So that one you will have to review this on your own. We have covered this much. All right. So just make sure that here the rules regarding the significant figures, so when you are multiplying, significant figure rules. So when you multiply and when we divide, multiply and divide, what do we get? Multiply and divide, we look at the significant figures, and the answer is the lowest significant figure. But when we add and we subtract, what do we get? When we add and subtract, we are using the lowest decimal place. So don't forget that one, lowest decimal place. Okay, clear? Right? So what else do you want? I mean, the conversions, next is the conversions. Next chapter, is about conversions and using the significant figures, right? Conversions and using the significant figures on that. So anything specific you have in mind? Okay, let's do this one, a few examples here. Okay. Okay, so let's say you have how many milliliters are are in how many milliliters? In 2.50 quarts. Okay, 2.50 quarts conversions. So here you are going to look at the table on your own. I may give the direct conversion, but I've given you the conversions here. So quarts and milliliters. Quarts and milliliters. So 1 quart is 946 milliliters. So 1 quart is 1 quart is equal to 946 milliliter. Okay, now here, so you know, for this, you use the significant figures. Answer should be based on the significant figures. So the two conversion factors are 1 quart over, and then 1 quart over 946 milliliters, or 946 milliliters over 1 quart. Okay, now 2.50 quart, okay, times, now we need to get rid of the quarts. So quarts will be in the denominator. We want the milliliters will be in the numerator. So we are going to use this conversion factor, this one. Okay, so 946 milliliters over 1 quart. So you cancel these two guys off. Now, remember that this is this part right here, this and this, these are exact numbers, okay? And for the exact numbers, we do not count. These are exact numbers. So we do not consider the significant figures for exact numbers, okay? So your final answer will only have the significant figures now based on this one, 2.50. So your final answer should only have two significant figures. So 2.50 times 946. Let's do this quickly. 946 times 2.50, and you have the answer 2365, and that's an exact number here. 2365. So you are having 2365, okay, milliliters. So that's the answer. But since the question has specifically stated, find the answer, find the answer, or to calculate the answer based on the significant figures. So how can you make this as 3 significant figure? That's a question, okay? So the question is specifically, otherwise this answer is right, 2365 milliliters is right, but calculate the answer based on the significant figure. So what are we going to do here? We will have to rewrite this number just to meet this criteria. So calculate the answer based on the significant figure. So according to the rules, our answer should be 3 significant figures, right? And we have here 2, 3, 6, 5. So to convert this into 3 significant figure, you will have to write it in scientific notation. Scientific notation. Okay? Scientific notation. So you have 2, 3, 6, 5 point. There's an implied decimal. Move it. 1, 2, and 3. So we moved to 3 places to the left. So here, what do you get? This becomes 2.36 into 10 to the power 3, okay? But we drop 5. And since it's 5, so what happens to 6? We add 1 to the 6 and it becomes 7. So the answer now is 2.37 into 10 to the power 3 milliliters. Okay? So we covered, scientific standard. We talked about the conversions and the rules. Okay, like that. Okay. All right, let's see. Done. Okay, next is, let's say if you have, this is one type of problem. Let's say some other problems, if you are given, let's say you have a question like, okay, let's say you have a number and they're saying round off, round up to 3 significant figures. And you have a number which is 2, 3, 4.789 and round up to 3 significant figures. That means we will need to keep this, drop 7. And you're dropping 7. 7 is more than 5. Therefore, you add 1 to the 4 and it becomes 5. So now this is the choice you will take. 2, 3, 5. So that has the 3 significant figures. Okay, so this type of question. Another type of question can be like, simple scientific decimal. So whenever there is a density question, density, because density is like, so density question, and then here these type of questions where there is an abundance factor, you have to factor in whether the question says significant figures or not. You still have to, do it based on the significant figures. So density questions always, because you're doing measurement, so always significant figures are involved. Okay, density. Now, let us say you have okay, let's say, so density, I mean, it's mass over volume, and then you divide the two so that you can do. And then addition, when you are adding, you just make sure that you are using the decimal places. Okay, decimal places. So don't forget these rules. These are not written in your handout. So if you forget it, you should write them down. Okay. So, I mean, anything else from this chapter 2? I would say, because chapter 2 and chapter 3, like the atomic structure, electronic configuration, writing the names, drawing the Lewis structures, those are like more like, like more engagement, more involvement, more questions are going to be from there. That's why I covered a lot in that, review, the first review I did, part 1. But in the second one, if there is something else you want me to do, then tell me right now. Otherwise, we can just move on to the next ones. Third. Okay. Other parts are like, you should know, these are all knowledge based now. Part 1 is like, you should know the general symbols of the elements, you should know, right? Symbols of the elements, and you should know their placement in the periodic tables, right? You should know which ones are metals, distinguish, which ones are non-metals, and which ones are metalloids. And then and then the metalloids are also called semi-metals. Metalloids are also like half metals. So some characteristics they will have of the metals. So know those symbols. Know the placement. Know the placement based on the period, right? Which period? Remember that after 4s is the 3D, even in the periodic table. And then the columns represent the group numbers. And just know the group numbers, and then based on the group numbers, know the charges. Very simple. We've been discussing that. And know the valence electrons also based on that. Okay. Then the general things are placement in the periodic tables, and then like the groups in the periodic table. The groups also, like, you should know what the halogens are, right? Halogens. Halogens are fluorine, chlorine, bromine, iodine, right? And then know which ones are the noble gases, noble gases, which ones are the, like noble gases are helium, neon, argon, krypton, xenon, radon. You know, the students ask me like the study guide, study guide, study guide, which means that I think they're expecting me to give them like what the exam will look like. Your exam is basically going to look like the quizzes, right? The question is given in quizzes, but there is so much in the chemistry. Even if I give you something, you know, it's not going to be complete. Like everything, you should need to know everything. So that's the thing. Okay. Then alkali metals. Know which group is that? Alkaline earth metals. Alkaline earth metals. So alkali metals are group 1A. Alkaline are, you know, 2A. So that sets you should know. Then you should know just in general the blocks, the S block, the D block, you know, the blocks, the S, D, SP and D, S, D, P and F blocks, like where is that element located, those type of things. Besides that, you should know what physical change is. Physical change is physical change and chemical change. Okay, what is that? So physical change is going to be like, you have to just visualize some of it. Physical change, you can recover, so it's just temporary. You can recover by very simple means, which is like evaporating. And then chemical change is more permanent change. Permanent is more permanent. Okay, physical and chemical change. So generally chemical changes will involve like burning, right? Or, you know, like a new substance will be formed, something new, like substance. And a new substance can be a gas, can be a solid, right? And there's also going to be some kind of a heat evolved, like heat exchange, like cool and hot, those things. um Physical and chemical change. What else is there? Properties that in general know, like, you know, what is conductivity, like conducting electricity, right? Conductivity, malleability, right? What does malleability means? Making things into thin sheets, malleable, right? And ductile is making things into wire, wires, right? A wire is ductile. Malleable is making them into thin sheets, beating them into thin sheets. Conductivity is with respect to electricity or and heat also. Something conducts heat or electricity, right? So just look at that. Look, I would say just look at the slides that are posted that have more information, like with the pictures and everything, which you can remember. Okay. All right. So there's a question here. Okay, we get to have our handout, right? Also, do we have lab after our exam? Yes, Vanessa, we will have lab after the exam. And I already talked about the lab, what we are going to do. So please see the announcement for the lab situation. But I'm going to give you you know, time, extra, little bit extra time. So not like a whole lot, but extra time will be given a little bit. Um, like I have to see how many students are waiting. So that thing. So anyways, so just look at all this basic things. And I think we covered quite a bit today. And if you have any further questions, you can always send me an email. Okay, I'm going to stop the recording now. And you can, I'm going to be here for some time and you can ask me more questions if you have. Okay.